Hi there, this is SP 5.3 and it has to do with probability. So describe, compare, predict, and test the likelihood of outcomes in probability situations. So our first indicator says, of course, describe situations relevant to self. We almost always have that indicator, something that's important to ourselves. So describe situations relevant to you that involve probability. And then you have to categorize different outcomes for the situation as being completely impossible, never going to happen, possible, which means, yeah, it might happen, or it's certain, 100% chance that it's going to happen. So, for example, is it possible that my little sister will be put to bed by 8 o'clock tonight? Well, yes, it's possible, but you never know. There might be something happen that she gets to bed later or earlier. Or is it impossible that I will have time to watch a movie tonight because I have 2 hockey games? Well, still, you could cancel the games and go watch the movie. So it is probable that you're going to go to hockey, but it's not certain. The next outcome, B, says design and conduct probability experiments to determine the likelihood of a specific outcome and explain what the results tell about the outcome, including whether the outcome is impossible, possible, or certain. So when you're designing an experiment, let's say up here, you are talking about the probability of a coin landing on heads. So it's possible that it would land on heads, but it's not certain, and it's definitely not impossible because it is one of the choices. But when you actually do the experiment, which B is talking about, it might happen that you toss the coin 5 times and it lands on tails all 5 times. So when you do an experiment, let me try and circle that word. There we go. When you do an experiment, it doesn't always come out the same way that the probability suggests it might. So we say the probability of a coin landing on heads is 50-50. You have a 1 out of 2 chance. It's either going to be heads or tails. So it's equally likely that heads or tails could happen. But when you actually do the experiment, you never know what you're going to get. You might get heads 5 times, you might get tails 5 times. So then in C, identify all the possible outcomes. That means how is it going to come out? Is it going to come out heads? Is it going to come out tails? What are the items that it could land on? So identify all the possible outcomes in a probability experiment, and then decide if they're likely, less likely, equally likely, more likely. So if we're talking about that coin, we would say, well, it's equally likely that they would be heads or tails. If you had a spinner, and you know those things that look like this, my drawing is not very good, but yeah. And we'll say this whole side is blue, this side is yellow, and this little corner here is red. So in C, the possible outcomes are, well, it could be yellow, could be red, could be blue. Look at that awesome printing. Yeah, okay. So those are our 3 possible outcomes. So we've identified the possible outcomes. And then we have to talk about less likely, equally likely, or more likely. So by looking at this spinner, you can tell that blue has a bigger section. So it's probably, it's more likely that our spinner is going to land on blue. In fact, if we had to measure out the odds, we could say, well, the yellow covers about a quarter of the board, so we have a 1 out of 4 chance of it being yellow. The red also covers about a quarter, so a 1 out of 4 chance. The blue, if we cut this part in half, there we go. If we cut that in half, we can see that there's 2 sections, so we have about a 2 out of 4 chance of it being blue. And then we can say this is more likely because there's 2 chances instead of just the 1 for red and yellow. Outcome D says predict the likelihood of the 2 outcomes in a probability experiment, carry out the experiment, and then compare the results to the prediction and identify possible reasons for discrepancies. Okay, so what this means is if we predict the outcome should be this, we have 25% chance yellow, 25% chance red, 50% chance blue. So that's our prediction. Right there, prediction. Then when we actually carry out the experiment and we get a spinner and we try it, let's say we spun it 4 times. We might get yellow once, and then blue again. We got blue, and then on the 4th turn, we got blue again. Okay, so yellow turned out that we got 1 out of 4, which is exactly what we predicted over here. Okay, that was our prediction. That was the likelihood, the probability. That was the theoretical probability. In theory, that's what we should have got. However, blue didn't really come out the way we thought it should. We got blue 3 out of 4 times, when the likelihood that we predicted was only 2 out of 4, and we didn't get red at all. So red was 0 out of 4. Gosh, my printing's nice. Okay, so sometimes, like D suggests here, that your prediction and what actually happens in the results, they're not the same. So identify possible reasons for that discrepancy. Now, discrepancy just means there's a difference, and it didn't turn out the way you thought it might. So in this case, we only spun it 4 times, so that might be a reason why we had a discrepancy, is that we didn't test it out long enough. Maybe we should spin it 100 times and see what we got, and we would have more accurate results, because surely if we spun it 100 times, it would land on red somewhere in there. Maybe one of the reasons for the discrepancy is that we didn't make our spinner properly, and it gets stuck and doesn't go on red for some reason. Or maybe we only spun it in a certain direction or with a certain amount of force, and it caused it to land on blue more often. So you can talk about the reasons for your discrepancies. If you're flipping a coin, it's just one of those things. That's the way it turns out, that sometimes your prediction doesn't carry out in the actual results. So let's go to the next slide. So here are all the words that I could think of, and there's probably lots more that you could put on a word wall and define that have something to do with probability. So there's the word probability. Possibility, outcomes, chances, odds, likelihood. So these kind of all mean the same thing. What are the odds that it would land on heads? What is the probability that we could roll a 6 on a dice? What are the chances of picking a jack out of a deck of cards? What is the likelihood of drawing a yellow ball out of a set of 6 colors? So these words all mean the same thing. These 2 words are what we just talked about on the previous slide, theoretical versus experimental. So theoretical is when we're talking about the odds. What is the theory? Well, if there's a coin that has 2 sides, the theory is that it would either be one or the other, and it's an equal chance of getting them, so 50-50 odds. But when we do the experiment and we actually try it, we might get something different. So theoretical odds are different from experimental odds. Lastly, these 2 things are important. Percent and fractions. So when we talk about probability, we can express probability as a percent or as a fraction. So just as we did on the previous slide, we used a fraction. We said, well, we got yellow 1 out of 4 times. And we know, because we're smarty pantses, that means 25%. Except I can't draw with the mouse. Yeah, there we go. All right, 25%. Now, if you wanted to, you could also express that as a decimal. There's my decimal, 0.25. So there's actually 3 ways you could express probability, in addition to using all these words at the top, because they all mean the same thing, the probability. Okay, so here's a couple of diagrams that show the outcomes. So if you're going to do your journal and they want you to draw a diagram, this would be a good one to use, because it shows that if you're flipping a coin, you have two options. It's either heads or tails. That's the only outcome that will happen if you flip a coin. You're not going to flip this coin and get a 7. You're not going to flip this coin and get a purple. Those are impossible. There's only two possible outcomes. It's either going to be heads or tails. And so each one of these outcomes has an equally likely chance, and that's why they've drawn this line right here to show that you're either going to have heads or tails. It's equally likely. So each one of those outcomes has exactly a 1 out of 2 chance. Over here with the dice, same thing. Every number on the dice has the same probability of being chosen. You have a 1 out of 6 chance.